Good morning, everyone. Welcome to the session on automation. I think it's going to be a pretty good session. We're going to start off with Sebastian Saw, who's my colleague at the Almond Board. He's going to kind of give a high-level conversation around some things that we're doing in remote sensing. And really, we're trying to get to this point of talking about how we come up with the how long and when to irrigate, right? And then we'll move into automation after Andrew McElrone speaks on a deeper dive into that process of using aerial imagery data to solve for ETA. So everybody's probably familiar with ETC, where you use a crop coefficient to come up with a number. ETA actually removes the need for the crop coefficient. So it's very simple. You don't have to worry about what crop it is. It's actually measuring actual ET. So, and then we're going to move into a panel discussion on automation. We've got a pretty distinguished group of people for that. Starting here with Guillermo Valenzuela. I never say his name right. I apologize for that. With Wiseconn. And then Andres Olivos. He came up from Chile. And in Chile, they do much higher density control than we usually do for automation. So I thought it would be really interesting to get insight into that, kind of where we could be going, right, with automation. Then Christfort from Ranch Systems. They're based in Nevada, so local, and very experienced in the space, one of the ones that have been around the longest. I really appreciated back in the days when I worked in the ag tech space. There was this whole thing where there was an exit strategy with startup companies. And I was having a conversation with Jakob, and he says, we don't have an exit strategy. We have a staying strategy. And it's really proved that out today. And then Andrew McElrone is going to cover the ET. And then at the very end is James Nichols with HotSpot Ag. So he grew up in the automation space as a grower that tried to solve a problem. And they've built a very robust platform for automation. So with that, I'm going to pass it off to Sebastian and let him get us going.
Thank you, Tom. So again, I'm Sebastian Sa. I'm the Associate Director of Agricultural Research at the Almond Board of California. I've been working in that position for about 6 years, and I get the opportunity to oversee the research projects that are anywhere from breeding to harvest, and of course, irrigation, nutrients, et cetera, and interact with the research community and so on. So I thought first, as a way of background, I guess, before I show you that slide, I would like to start by mentioning that we have funded research in irrigation to increase water use efficiency for a long time. We have together moved from unpressurized systems to pressurized irrigation systems and greatly improved our ability to efficiently irrigate our almond trees by doing so. And by funding research in irrigation, we have also been able to fine-tune irrigation practice all year round, especially around hole split in preparation for harvest or in connection of how to improve tree health by avoiding diseases like Phytophthora or hole rot, among others. So building on this foundation, we collaboratively developed our new irrigation strategic map. And that was about 5 years ago, and it's illustrated in this slide that you can see here. So this is our ABC irrigation research portfolio. This is what we agree with all of our stakeholders, many of you here in the room, after multiple discussions on what we should fund and what we should focus next. So here you can see the 4 cornerstones of our research portfolio, those bubbles that you see there, where under each of them, we have aligned different research projects to better define when to irrigate via 3 sensors, which that's the first bubble, how much and where to irrigate via actual and understanding spatial evapotranspiration, actual evapotranspiration, to ultimately mix that information with tree performance in a smart and practical manner to prep ourselves to maximize the use of new technology such as automation. And we think that will allow us to make that jump from today to the future, a future where we continue to increase our water use efficiency. And along with these bubbles, we have already presented to you our latest discoveries around 3 sensors. The first bubble, where we have identified new sensors that can directly measure stormwater potential values automizing the stem water potential pump tool, which we know, even though it's a great tool, it's very labor intensive. We focus our previous two conferences on that first bubble, and the researchers are also available in the poster sessions if you still want to know more about tree sensors. And today, we're going to be talking about the second bubble that you can see here, the research around actual tree evapotranspiration, which we see again as the potential evolution of how we define how much to irrigate our orchards nowadays. So, sorry. Is that it? Yep. So when we talk about research around actual tree evapotranspiration, what we really mean is further helping growers irrigate the right amount. And before I go there, I would like to recall how we took that decision today, a little bit what Tom was mentioning. So far, the common method to define the right amount is via the calculation of cultivar evapotranspiration known as ETC. Not to be confused again with ETA. So ETC, you can see there in the screen, probably many of you are familiar with the equation. It's really an indirect approximation of how much water is used or transpired by our trees. And to obtain this ETC number, irrigators multiply a reference ET, which is the amount of water used by a well-irrigated mowed grass, by a monthly crop coefficient to correct for a specific crop, the KC. So in other words, irrigators use indirect measurements to prescribe how much water they need to apply to their trees. But I think we know that we would like to do better than using indirect measurements and assuming that all mature orchards transpire the same in a given region, so at a given time. So that, I think, was kind of like the main motivator to move into the ETA component. So again, with all that background on the table, we started to look into new methods that could directly visualize the amount of water that is being transpired by our trees at a given time instead of using referential values, and so improving our ability to differentiate tree water demand by orchard age and variety type, among others. So really look into more site-specific conditions and move a little bit away of the referential values. And after multiple conversations with different research teams and other partners, we decided to support a comprehensive tree-crop remote sensing experiment known as the T-Rex. And as you can see here, it's quite multidisciplinary. It has multiple funding agencies. We are one of them. And I think that this experiment does not only help us to solve for actual evapotranspiration, but also offers the ability to observe field spatial variability in terms of transpiration, which is key for further leverage automation, which is what they are going to be discussing later in this session. So that being said, I will yield the rest of my time to one of the research leaders here, Andrew McElrone, to tell us more about this exciting project and its latest results. Thank you.
Just advance.
Yeah, green.
Okay.
And then backward, there's no point.
Okay. Good afternoon, everyone. Thank you for the opportunity to be here to give an update on the T-Rex project. So I'm Andrew McElrone. I'm a USDA scientist based in Davis. And I am actually one of a small number of people that are actually involved in this project. While I'm the one that's up here speaking, it's a huge interdisciplinary team. There's two individuals that I'd like to call out that are actually in the audience, and you can direct questions to them afterwards as well, too, so deflecting a bit. Nico Baumbach and Kyle Knipper have been instrumental in the work that we've done on the T-Rex project. Nico on the ground-based sensing systems and Kyle on the remote sensing side of that. And I'd also like to thank the Almond Board right from the beginning in terms of the initial seed money and the idea of getting us together with other research groups for this. So they provided initial funding that we leveraged, turned into CDFA funding, which is about $1 million at this point. And then USDA has invested several $1 million into this in terms of salaries of scientists from 4 different locations across the country, as well as equipment for all of these different sites. So thanks to all those people for coming together for this. So we actually, we have the old slides here, Sebastian. It's funny. Sorry, I'll keep going. We are really interested in quantifying orchard water balance as effectively as possible. So we want to measure everything in the system to give you the information that you need to deliver the water to where you want it in order to grow the crop productively. We're laser focused on evapotranspiration for this. Measuring all of these things really effectively is becoming more important in terms of the policy side of this, with SGMA coming out and the need for the quantification that's coming along in the regulation associated with it. We are dialed in on these questions associated with irrigation. So how much water is needed, when to irrigate, and where to place it. So those are related to tree water use and the ET. The when is associated with the crop stress, and where is associated with the spatial variability that we see. So remote sensing gives us the capability to do this over much larger scales than we've been able to do in the past, and to really help you achieve production goals and to meet those policy needs that we have. So I'll pass over that since Sebastian covered it. Our T-Rex project grew out of the GrapeX project. So this was a partnership with E&J Gallo. We had numerous vineyards throughout California where we were actually measuring on the ground the water vapor that was coming off of that surface in terms of the crop ET, and comparing that against remote sense models that you can see in the bottom left of the image here. So this maps ET down to 30 by 30 meter resolution and provides that at that scale. And we also are doing this with drones that get it even to finer resolution. What this work has entailed is a lot of work on the ground. So we put research grade sensors on the ground that can actually measure the water vapor coming off of this, as well as having an army of people. Every time the satellite would pass over, we would have people on the ground making measurements to make sure that what we're seeing at the leaf level matches with the satellite level. So we use that same concept moving into T-Rex. Some of the secret sauce behind this is really based in energy balance approaches. So we are looking at this from the point of view of trying to get at the latent heat flux. So shown on the right-hand side of this equation, that's the energy that goes into evaporating water in your cropping system. So we can measure that directly. Like I mentioned, we have sensors on the ground that are doing that. But there are lots of other ways to get at that with these energy balance approaches. So the net radiation represents the energy that goes in and is available for evaporating water. And we look at how much of that goes into the ground in terms of the ground heat flux, and then how much of it goes into heating the air in terms of the sensible heat flux. By measuring those first three effectively, we can then calculate how much is actually available for evaporating water in terms of the latent heat flux side of this. The same principle is used across all of these scales, whether it's on the flux towers in the cartoon shown on the bottom left, or in the drones or at the satellite scale. We use the same approaches. And behind a lot of the commercial methods that are out there, it's the same principles that are at work for all of these. And it's good to actually be aware of what's actually being measured in each of these systems. So those same principles are applied to the satellite scale. So on the right-hand side of this, it shows surface temperature across the continental US going down to a very fine scale that's measured with a drone. And then that is translated into these ET values. And you can see in the bottom right-hand side of that field scale comparing corn and soy, which you may not be able to see on the slide, but down to that sort of resolution where we can see what the ET differences are between these. So those energy balance approaches are the exact same thing that are used in the satellite models. On the left-hand side shows the two-source energy balance that we use in the Alexi-Disalexi model that Kyle works on for our remote sensing approaches. And that partitions the energy that's going into fluxes from the soil and from the canopy itself. So we have those two sources from the soil and the canopy. So when Kyle is doing his model, he starts with Alexi at 4-kilometer resolution, and then they iterate, and this gets disaggregated down into 30-meter scale resolution. And I'll come back to that idea in terms of one of the research lines that we have going on. So this shows a simpler version of that, of where we can distinguish between the tree transpiration versus the soil evaporation. And it's particularly useful in the example that's shown on the bottom in the cartoon there. If you had either a soil flooding event or rainfall where you're getting more uniform distribution of the water, you would actually see that soil evaporation have the capacity to distinguish those two things in the system versus a more localized irrigation event. In T-Rex, we actually modeled this off of GrapeX, and we had multiple sites that we worked with in commercial orchards. We had one in Woodland, one in Vacaville, and one further south down in Ripperdan. And it gave us the possibility to look at different varieties and different canopy structures to make sure that those models and that we're representing the almond canopy most effectively across these sites. We also coordinated efforts with Patrick Brown's group, who just walked in the room, on the single tree harvesting project, where they're getting values of yields down to the single tree. Almond Board suggested that we all come together at one site to really leverage resources to get more information out of this, and we're doing that across these sites. So this is a cartoon representing what we actually do on the ground. So on the left-hand side, it shows when the satellite is passing over. We'll also have drones flying for much higher resolution remote sensing, and then we have the towers on the ground. We send out an army of people in the bottom panel on the right doing measurements at the leaf level with things that we understand in terms of stress physiology. Drones are flying over during that time, and we do diurnal measurements throughout that. And in the upper center panel, we have the flux towers that are actually measuring the water vapor and CO2 fluxes. This is just an example of some of the ground truthing that we've done from 2021 to 2023. We started this during COVID, where we were trying to stand 6 feet apart while installing towers out in the field with a lot of help from the growers and backhoes to establish these 40-foot tall towers that we have in the field. We have a lot of soil sensors, sap flow sensors in there, maintain these throughout time, and again, do a wide variety of measurements. This is just an example of the ground truthing efforts that we did in 2022, where we visited every site at least once a month during the growing season for all 3 of these sites. We also partnered with 2 different research groups. Malika Noko on the bottom works on drones at UC Davis through UCNR, and Alfonso Torres Rua is from Utah State, and he has been working on drones as part of the Aggie Air Team for a long time. And I wanted to show an example of the practical side of this without getting into too much data. This is from our most southern site in partnership with Olam, where we actually have within one orchard lots of different opportunity to look at coverage of different canopy shapes and coverage within these almonds. So plots 4, 5, 10, and 9 are all the youngest there. They have the lowest coverage. You can see that from the images that are represented from it. Across the top of this plot, you have 3, 2, 1, and 6 are 5-year-old orchards for when we were doing this imaging. And then the oldest are 7 and 8, and they have the most coverage and the most shaded area under those in this. So when we actually look at this for age-specific management, which has been a problem in almonds for a long time, we have young trees versus old trees and how you distinguish between those. We're starting to see that the remote sensing tools can actually provide us really fine resolution for precision irrigation management. On the left-hand side of this, you have the NDVI plots. That doesn't show much difference. So all of the youngest ones are clumping together. You have those intermediate age ones looking similar across the top in the NDVI, and then the 2 oldest coming out looking similarly. But when you start looking at the leaf area index, you start to see more subtle differences between these. So you can see even amongst the young, there's differences in the leaf area index on those plots. So how much leaf area is there to actually evaporate that water? And that translates directly into the differences in ET that we see in the 3rd plot from the left-hand side. So even within those that are 5 years old, the 4 plots across the top, you see 2 of them having much higher ET compared to the other 2 on this plot. That would require different irrigation amounts, and we would want to deliver according to that. The other thing to point out here too is you see a lot of within-site variability. So that whole block is not the same. It gives you some pointers into weak spots within that to bring that into uniformity for that entire site. This is an example of Kyle's mapping of ET across 2 of the major domains where our field sites are, and just an example from June of 2021 of the breadth of the data that he's mapping for this and differences between our almond sites, going from the northernmost in Woodland down to the one in Olam, where you have much higher transpiration rates represented by the darker colors there. And that site in the center, the Vacaville site, showing a lot of in-site variability here. And this is the other thing that the remote sensing can do for us is in the plot along the bottom, it shows the average value of each of the pixels within that remote sensed area for this Vacaville site. The dark blue line is the mean value of the ET there. The intermediate blue color is the standard deviation from that mean, and the range is pixels, the highest and lowest pixels are shown in the lightest blue there. We found consistently when I went into the OpenET to look at this, those weak pixels were always weak, and it points to spots then that you could go in terms of management to bring that up, whether it's from soil differences or other things, and potentially for laying down the irrigation right from the beginning in terms of that as we move into automation and things. Our data is going out through OpenET. In that platform, Kyle is actually the representative for mapping agricultural ET in all of California. And it's a huge partnership with Google Earth Engine and NASA and the Environmental Defense Fund to put this out there in cost-effective ways. We are not selling something, at least in our unit, and this is available to both PCAs as well as other companies to be ingesting this data into the data streams that are going out in this way. I will skip over these real quick because they had disappeared in my version. And then I wanted to touch base on the science real quick here at the very end of it before finishing on a few directions that we're going. So one of the things that we are doing to continue to refine the models that we're working on, Kyle came up with a unique way to actually deal with effective conditions. So that energy balance approach that I was talking about is within the models from the remote sensing, they don't handle horizontal transfer of energy into the system. And so what we have in some conditions, as shown here in the bottom center of this, you have large grasslands that serve as a very large heat source during the middle of the summer. That grass dries up, it generates a lot of heat, and that will blow into the almond orchard, and you'll see these edge effects from this. This can mess with the models, and you actually see that in the data stream in the top part of this, where the blue data points from the towers, where we're measuring this on the ground directly, are higher than what the model is actually predicting, because it's not seeing that horizontal transfer of data coming in. We've quantified it. The image on the bottom right actually shows how we're measuring that energy coming off of that open grassland. And so what Kyle came up with to deal with this is a synthetic Alexi product. So in the bottom left, that 4-kilometer resolution of how Alexi typically runs, you can see the black rectangle that's there. It doesn't particularly represent the leaf area index right above it for that plot because you have all of this open grassland. So what he did was create a synthetic Alexi that better represents going down to 500 meters, the plot itself, and represents the LAI. And when he does that, and you look at this data, you go from the black line in the center of this plot, and by starting with the synthetic Alexi at 500 meters, you start to bring that in congruence with the gray line that's at the upper part of this, which is from the flux tower. So those green data points are then the result of actually doing that modeling of starting with a better point. So looking to do this and deal with some of those edge effects. So what we're now working on and moving forward in terms of deployment is site and orchard-specific optimal ET product. So really accounting for these types of things that I just mentioned. Kyle and a graduate student is working on a near real-time actual ET forecast. So projecting out, imagining a heat wave is coming, how much water am I going to need relative to what's actually in the soil? They're using a machine learning approach with a physics-informed neural network for this. And the data for this is actually showing really good promise. And they're doing this in a retrospective way of using old data, using the remote sensing data, and combining those things to see how we're doing moving forward. And we can give you more details about that. And then finally, we're working to develop a data fusion product that's based on both ground-based sensor as well as the remote sensing. We've been developing ground-based sensors for quite some time. Here is an example of one of those using these infrared radiometers that have been long used for detecting the canopy temperature, similar to taking our temperature and measuring stress in that condition. We started playing around with this, using them at higher frequency, and realized that we could actually detect the sensible heat flux from this. And that's actually shown on the figure on the left is from almonds, of where we're actually getting really good correspondence between this new wavelet method in terms of the ET that we're measuring on the ground by looking at the canopy with this relative to what an eddy covariance system would be doing. It gives us the possibility of detecting stress and water use at the same time, doing this in real time, and then separating out the tree or the vine, as written here, from the cover crop itself, and to be able to distinguish that and pair it with the remote sensing. And then finally, we're working on adoption trials and extension for this. And I'll finish with thanks again to a huge team that's involved in all of this, and happy to take questions after the panel as well. So thank you.
Thank you, Andrew. And we're going to let him escape if he doesn't want to field these automation questions. So automation. So as we move past this, where we've done a good job of providing tools like this to help really solve, like I said before, that how much water do we need and when do we need to apply water. And if we look across all our practices growing almonds, the one really weak spot that we get hit on constantly is our water use. And over the years, we've made huge strides through micro-irrigation, drip irrigation systems, monitoring solutions to improve our water use. We need that next strive. We need that next big jump that we can make in water use. And when you think of this data, and I've seen this a lot with growers, and I've worked with growers a lot using these systems of understanding their water needs. I'm sure everybody on this panel has dealt with this with their customers, that they're pulling in data, they've solved this when and how long, but they're not executing on it. We feel we're good, right? But we're not making those fine adjustments to our irrigations. We're not capturing that savings of 15 minutes next week that we could pull back. Or there's a heat spell coming in, we need to really bump it up. We're not following the resolution of what ET is, or ETC, ETA. And our limiter is really automation. Automation is the tool that allows us to let the system do it. It doesn't matter if Bill had a problem on the other side of the orchard that he had to go take care of, and he didn't get back to the valve for 2.5 hours while he was fixing it, right? The system takes care of that. It lets you deal with these small fluctuations throughout the year. It's not just water. It's nutrient savings, it's energy savings. So this is a big topic for us at ABC this year, is looking at how can we move forward with automation. So what I'm going to do with the panel is I assembled a list of questions for them to kind of seed us and get us going, and then we'll have some time for everybody here to throw some good ones at us. So anyhow, with that, so just kind of get us started. When you look at your customers now, what's holding them back from automating? And I'll just ask that to the whole panel. What do you get from customers where I'm not ready to do this automation, I don't believe this or that, or what's holding people back from automation at this point? Who wants to go first?
There's a lot of things, so where do you want us to start?
Should we just pick one?
We'll
and
probably
then go
keep this
down the
fairly
panel?
short.
All right. Well, I think one is could be the economics of automation. There can be some high upfront costs. We'll talk a little bit more to the benefits, but just to answer the question, I think economics is one thing that holds growers back from adopting more automation.
Well, if I had to choose one, I would say that a lot of growers have had bad experiences. They may have, and I don't think any of the vendors here are to blame, but there's a lot of other vendors that are not here at the table who have been out there with technology that might not have been ready. And that has given some growers a very bad experience. And it's hard to come back in afterwards, no matter how good we are, to when the grower has been burned.
Yeah.
I think if I had to choose one, would probably be the training offered, and that actually growers also invest on training their irrigation people. So there's skepticism of them running them. I'm from the same irrigators. I personally have the experience of had to train irrigators on how to use this, and the first 5 to 10 minutes, it's nothing but, you know, not receptibility at all. They don't even hear about it. And then a couple of weeks in, they're liking it, they're getting used to it, and they end up loving it. So there's this misconception of this being, you know, rocket science, which is not. We've worked hard on making it simple, or as simple as we can, so that anybody can actually run it. And I think that has changed in the last few years, where before they were very complicated, so the actual irrigation workforce was not ready for it, but that has changed now. So there's more need of being willingness to train the irrigation force on it.
Well, I think we haven't put a price to water, at least in Chile, so it's super cheap. So up to now, growers, they are not facing with water scarcity and water high prices, so basically they don't want to. I mean, and what we face in Chile is a little bit different here because we do a little bit more of automation over there. So for them, it's really easy to turn on and off irrigation a specific valve. So it's not a top on the list. I guess that's one.
So on the flip side, customers that you've worked with that now have put automation in, have embraced it, what are the type of benefits that they're seeing and the advantages that they've discovered by utilizing an automated system?
Well, I think you mentioned the classic, saving energy. We've seen like a straightforward benefit. It's just, staying around peak hours to run the pumps, run at night without having to add, overtime on the irrigators. So you got a little bit of energy savings there. You got labor savings if you're not paying extra labor for the irrigators. The irrigators are not actually opening and closing valves anymore. They're still walking the fields. They're flushing the lines. They're unclogging the emitters, but they're not responsible, opening and closing a valve. At $100 a day for an irrigator, that's actually an expensive controller. So there's an economics there on the energy and on the labor side for sure that has been benefits that I've seen growing.
That's an interesting point, that's an expensive controller. It's
is.
very true when we look at the cost of a staff person.
Yeah, especially
and we think of the cost of a device in the field. It seems expensive at the beginning, but over time it's
and then you got the truck he's driving, he's burning gas, and sometimes there's human error, which is hard to quantify. But if he's got to run an errand at home, he'll just leave the pump running until tomorrow, and that was energy. Maybe he flushed fertilizers. There's a whole lot of things that happen when you're running manually.
I just want to echo that. I talk to a lot of owners of operations that are not necessarily close to the operation themselves, but are very concerned about how it gets irrigated. Say a winemaker that's not actually part of the vineyard team, automation enables them to know what actually gets irrigated. I've talked to many winemakers who said, I've told them how much to irrigate, but I know it's not what's being irrigated manually.
Yep.
But when it's automated, I know.
I think Guillermo highlighted some really great first-year benefits to automation. Some of the longer-term benefits of automation is really, tree health and productivity. When we first started trialing the automation on our own farm, we had some troubles with disease and nutrition management. We implemented an ET schedule combined with automation, and the first year didn't see the yield improvements, but we saw much better leaf nutrient analysis. We didn't have to spray for mites as a result of higher K levels, and then second, third year after that really started seeing the yield improvements. So both short-term cost savings and then longer-term revenue benefits.
I think for us, the great benefit is just to, that enables you to manage that variability that Andrew was talking about, right? So here we are really focused on how to address that variability and put the exact input on which block you are irrigating. So I think automation, for us at least, enables you to manage differently. So for instance, we have been working with prune growers over there that irrigates like 50% less than ET. But that means that there are some blocks that you irrigate exactly the T, and the other ones, and with the right technology, for instance, in this case was regulated deficit irrigation with the stem water potential or the floral pool sensors, for instance, you can irrigate as much as the T, or I don't know, even 30% of the T depending on the soil. So then it's savings in energy, that it's saving in water, and it's savings in fertilizer. So, but you cannot address that without automation.
I worked with a customer kind of in the time savings perspective, who he was amazed by the windshield time that he reduced once he went to automation. Because he was driving from orchard to orchard to see that things were happening on schedule and what the plan was. And their operations spanned about 4 counties, and he was constantly driving in his pickup. And he said, man, it saves me so much time in my pickup. I can just pull up on the computer and I can see what's going on. And the comfort from that was big. Guillermo, I know that you had a customer that to help overcome infiltration issues went to pulse irrigation, where he's frequently irrigating. This is something that's really hard to do manually, right? If you're doing 3 or 4 hour pushes, that's a lot of activation of valves. Can you speak to that?
Yeah, we've seen, I mean, it's impossible. And specifically that guy that you're mentioning, that I know who you're talking about, he had 60 valves on a 150-acre ranch, and he wanted to open them 10 times a day, each one. So it was impossible. His brother did it for a few days. Then he quit. So we've seen a lot of the tendency towards high-frequency irrigation, or pulse irrigation, people call it, because there's several benefits around it. In terms of water consumption, you're just basically putting water to certain depths. If you're not going below 18 inches in almonds, is what we've seen. So you're basically irrigating the trees like they were in a pot. And now it's got its pros and cons, like everything. You don't have a reserve water underneath, so you don't. I mean, if you have a problem with the irrigation system, you only have a couple of days before you're stressed, fully stressed. But we've seen this tendency, especially because it helps you irrigate across the board all your different soil types. When you do high frequency, you don't have any soil type that's suffering. So now you're irrigating every day, twice a day, 3 times a day. We got a bunch of growers that have adopted that, gone on pistachios from once or twice a week to 2 times a day. And they love it because now their sandy soils are not hurting because they're irrigating high frequency. Their heavy soils are getting the water that it needs because the high frequency is also getting there. Sometimes they combine it and they put a longer run once a week just to fill up the tank, build some roots. But a lot of people have gone there because it helps you reduce the soil variability issue with the high frequency irrigation. Now this guy specifically did it because he had 2 500-gallon per minute wells, and he lost one on the first week of July. So he either stopped irrigating.
So he's short on water.
He was
so it allowed him to get across these orchards.
He was forced to. He had to go from 1,000 gallons a minute that he had on his both wells. He went down to 500 mid-season. He was like, I either stop irrigating a piece of the ranch, or I'll just spoon feed the water to the trees. And he started with 1, 2, 3 times a day, and then a couple of years later, he just went crazy and was doing 10 times for 20 minutes. And
but really, you could not do that.
Oh, without automation, it would be impossible.
It would drive your staff crazy. Right?
And then there's the simplicity you were mentioning, and we read at some point a research from UC Davis on what the growers were looking for in the Central Valley, and at the end of the day, they had so many issues during the summer that they basically want their life to be a little bit more simple. And irrigation is a big topic during the summer.
Right.
So if you have the information on your phone without having to hop, on the truck and go check what's going on, or if there's a pressure alarm, or if there's a flow alarm, or a pipe burst, and 5 minutes later from your phone, you're reacting, and it simplifies your life. Even if you don't want to do 10 times a day irrigations, you know what I mean?
So you raise a great topic, and Jimmy, I know that you've dealt with this a lot, and a lot of growers have asked me, well, what if my pump deadheads? What if I have a break? Maybe speak to the way that you identify things and challenges and problems when things don't go right, and can the system accommodate that, or am I overflowing the canal and having the water districts making that really pleasant phone call to me?
All right, so you get to let Guillermo talk about the benefits, and then you tell me, or to talk about when things go wrong?
Yeah, I want you to deal with the problem.
I got to take the nice part.
So yeah, one of the best thing to think about when things go wrong, are first during the introductory walk with an automation vendor. So the grower has an idea of what possibilities can happen, and sharing those with the vendor to set up the proper alarms is one good step to prevent things from going wrong. So with HotSpot, things generally go wrong, or things can go wrong during the first first couple weeks or months of a new installation. And yeah, training is important, but you know, when things do wrong, being notified by text or email of something that happened, and then having trust in the automation to turn the pump off or open a valve to relieve any pressure is what we strive for.
Yeah, yeah. So another area that I get asked a lot about is this is going to be really complex. It's going to make my life a living nightmare to manage this. Andreas, you deal with a lot of valves, right? That's a lot of instructions. How do your growers deal with building those irrigation schedules? And are they married to their computer, or is that a fairly straightforward process? I've heard growers say, I don't want to be sitting in my office all day long controlling my irrigation system.
Yeah, I mean, that will depend on the grower strategy, irrigation strategy, I would say. But the systems nowadays allows you to save the schedule. So sometimes when you see ET, Andrew, year by year, of course, there's some variability, but I mean, you can, based on historic data, do something about it, right? And you can save the program. So I would say—
So you're just reapplying.
Yeah,
Yeah.
I mean, but you start learning on a yearly basis how to adjust and fine-tune the system. So I don't think it's a problem. But the other thing that we receive a lot is how do you think that is safe, if the program is safe? I mean, and it's always safe. All these new controllers, they have conditions that you can put on it, right? So what happens if a pipe burst, right? So you turn off the irrigation. You get an alarm, and if it is more than 10 minutes, then you just shut down everything. You can say with conditions, and it's not a programming or whatever, it's not coding, it's just the allows you to do the equipment, do something for you.
Yeah.
Right? If the reservoir is low, then just start the pump well to feed the—
So there's a fail-safe, so if I'm having lunch and my phone's
Right.
out in my truck and this happens and I
Yes.
don't respond,
I
it
mean—
shuts down.
Yeah, and I agree with Guillermo. I mean, we have built these systems to be super simple,
Yeah.
to make growers' life simpler.
Yeah.
Not to be—
We try.
Oh,
And Jakob, I've seen for some of the things you're doing, you allow for the real advanced users a lot of flexibility to do. I mean, basically, it's custom scripting. If this happens, do this, right? Can you kind of speak
Yeah.
to kind of the high-level opportunities that maybe are out there?
And this is, as I said, definitely not a first-time irrigating farmer that would get into this kind of thing. But for the more advanced users or irrigators, or maybe in some cases it's really our resellers that step in, you can kind of, we have a little formula scripting language that you could compare with Excel spreadsheet kind of skill level, where you can create relationships between things like ET, things you might have sensed on the sensing side of your system, and then feed that in to your irrigation schedules and create anything from, I mean, a typical example is that you take ET and say, based on the ET, some boundaries of ET, you throttle the budget of the irrigation program. That would be the simplest thing to say. ET over this, reduce the budget to 70%. I mean, that would be the very simplest formula. But then you can get more and more advanced. You can take other things into account, like the wind speed. Is it very windy? Although that's also in the ET. But you know, if there's rain in the forecast, do I even want to start irrigation? I'm just going to rely on that water coming in. You could build that into your formula.
In the budgeting, it's kind of like my lawn controller. I can say, then I'm going to turn my budget down from kind of a baseline budget.
Yes.
Yeah.
Because we don't want to get into, I mean, you could build, if you really wanted to go crazy, you could build individual irrigation based on formula. But for most people, they got a baseline and then they just throttle that volume
Up or down.
volume
Up or
button.
down.
It's
Yeah.
the most manageable.
And I think that's the thing that I want everybody to know. I remember when a grower came to me about 20 years ago when I was up in Durham and he wanted to put an automation system in. his desire was ahead of the industry. Now, I think the industry is ahead of growers, what the options are that are available. It's quite robust from what it was 20 years ago, you know, so, yeah. So when we're looking at and moving into a control platform, I mean, maybe speak to what's simplistic. I mean, if I just want to do my pump and I got 2 valves at the pump station, pretty straightforward. But what are you seeing? Are you recommending growers put valves at the pump station, do field valves? Maybe speak to that.
Well, there's all level of complexity that you can get off the system. Okay, so we got people that start off very simple, just in start and stopping the pump, and that's all they have, and all in the field is butterfly valves, so you don't get to make many changes there, all the way down to spoon feeding the fertilizer in a proportional way to make sure that I'm injecting fertilizer every time I irrigate. We've got guys that are irrigating by variety, so we got a valve for the nonpareils and we got valves for the Monterey's or Sonora, so we're irrigating by variety. We are doing all sorts of, not complex, but we are basically cycling through the valves to maintain, pressurize the system so we have a better distribution uniformity. Soil-specific irrigation, pulse irrigation, there's all sorts of things that you can work with and get very complex to the point where you're separating the valves per soil type because you want to irrigate the sandy soils with the sandy soils and the heavy soils with the heavy soils. Or just as simple as a timer, like the one you were in your lawn. You can like run it very simplistic and just have something like roll over every week the same thing, or you can get all the way down to, you know, monitoring the electric conductivity in the water when you're fertilizing and make decisions around that, or even maybe even inject the fertilizer based on the reading of the electric conductivity. So the systems have been built for you to start very simple and for you to go all the way deep as you want, actually. So it depends more of every case scenario. Every ranch, I would say, have different needs, and everybody here knows that every ranch has a different particular, the water source. If it's, do I have a live canal? Do I have a well? Do I have a reservoir? Do I have a fertigation system? Do I have money for fertilizers? You know, at the end of the day, it's, you know, it depends on the level of complexity you want to dive into. The systems usually accommodate to what you need. But you can start very, very simple, just monitoring a flow meter for sigma purposes, and start from there.
Yeah. So I'll open a hot topic. It'll be interesting to see the responses. When we're talking about infield valves, wired, wireless, should I be putting wire in at the point of development? I mean, if I was developing a brand new property, would it benefit me to run wire out to all my field valves? Or would I be better to go with wireless solution, or are both gonna work for me? This will be we'll start at the end of the table and let's see how this moves as it moves down the table.
Well, yeah, there's
We'll probably get differing opinions,
Okay.
but that's okay. Right?
Yeah, I mean, there's pros and cons to both. I guess starting out with wired, the advantage is if it's done properly, if it's put in conduit or very heavy rubber, it's down deep, you know, next to, like, say, a main line, could be a very reliable control solution for infield valves. One of the downsides is that you generally can't get feedback as far as how the valve's performing. If you want to know pressure, you have to run, you know, quite a few more wires just to get that. But yeah, it could be a very valuable solution prior to installation going in. To run wire after the fact is probably cost prohibitive. But I guess as far as a disadvantage, if you're running a chisel and clip a wire, you could be taking down your entire system, and could be a while to try and figure out where to fix that wire. So advantages for infield or for wireless or cellular, you know, they run on their own solar battery. So if a tractor hits one of those, you know, one station's going down, it may not whereas cutting a main wire can take down the whole system.
Yeah, I agree with all of those. I think if you have wires and they're in good condition, I think you should absolutely use them. They're good thing to have. I think it's more a consideration if I don't have them, do I want to spend the money putting them in versus just go with wireless? Wireless will probably be cheaper because you probably want feedback sensors at various places anyway, so you could argue that wireless node is almost free for the valve. So it's going to be a big cost difference if you don't have the wires already.
For me, it's no wires. I mean, I just got the number from our company down in Chile, and in our projects, 93% of the projects are without wires. New projects without wires. In terms of if you already have the wires installed and then you found something is not working, we studied with, for instance, with a big company, Conchidor over there, that is not worth it to just keep doing with wires. They just put an antenna and that's it. And then they can receive as well back, they can receive information from the valve, they can put some sensors on it, they can use it as a repeater for another antenna. So, I mean, we are going for not using wires anymore. I mean, and we should stay the same.
And in Chile, they steal the wire.
Yeah.
So it doesn't last long.
Go ahead.
So yeah, no, you have the burglary issue, especially over there.
Well, we are 3 Chileans.
Yeah. So, but so yeah, I believe that I think I mean wireless. Wiseconn comes from wireless sensors connections actually. So we like wireless. But having said that, we end up using a hybrid actually. So we do like long shots on wireless radios, and then we run some wire to be able to connect
So
several.
you can do a blended system.
So you do a blended, and usually what we do, if the wire's there, like Andres was saying, and then one valve stops working because the wire got stolen or whatever, you just put one antenna and you put that valve on wireless, and the rest stay on the wire as the wire works, as long as the wire works. But even on new designs, we've been working with companies, so when you're doing a new development, you cluster the valves together, so your automation and your control system is cheaper because you're putting up to 5, 6 valves on one controller. Even if you have to run 100 feet of wire, you're not running miles of wire, and you're just running very short, shots of wire just to be able to control several valves on one controller. So that's kind of the way we go. It's more of a hybrid, I like to say. But then outside of the almond industry, there's other crops that actually work with wire, and you don't have, I mean, on veggies, on processing tomatoes, on some of these guys that have the sprayers that are really low, the wireless has the problem that you have to have the antenna, so you have a pole, or on wine grapes, you have to be removing the poles in order to harvest. So, as I said, every ranch is different, so at the end of the day, when you're choosing one or the other, you probably want to go with a solution that will do both, that has the flexibility to do what you need, depending on the crop and how you're planting, if the valve's in the middle of the block or if it's in the road. There are some things that need to be taken into consideration at the moment of the design. Traditionally, in California, in almonds, especially in the southern part of the valley, there's a lot of butterfly valves, big blocks. You're irrigating 100 acres at a time, right? And then you have the other problem, which I see a lot, is that they put a big valve to put one antenna to control one valve that is a 12-inch or a 14-inch valve to irrigate 100 acres. And then when you shut that valve, the whole sub-main drains into the lower part of the ranch, and then we don't know why we have standing water on one side of it. It's because you didn't automate the 15 valves downstream of the big 14-inch valve, so you drain the whole main line. I know everybody has gone through the drainage here. So, that's the kind of things that you start deciding, okay, you know what, I'm not going to automate the big block valve. I'm just going to put a butterfly valve at the zone valve, and I'm going to go and automate the little block valves. So I don't have drainage, so I can potentially switch the block. Now I'm not irrigating these valves in this zone that was designed to, because it matches the soil on the other side of the ranch. So I'm wireless, so I'll just move that valve to this block and these 2 valves to this block. All of a sudden I have combination of blocks. When you're hardwiring, you're hardwired, man. There's no choice, and you would have to rerun the wire.
And you raise an interesting point on big valves. I did some analytics and economic studies on doing few blocks with big valves to many blocks with really small valves. And I was surprised, small valves cost a lot less money.
They cost less money, and in the long term, since you have a big pipe and then you've got a lot of small valves, you got less friction, you got less energy consumption. So if you annualize the cost of the energy of running your irrigation system for 20 years, and you go put the energy equation on it, and you bring it down to the present value, running a system with low cost energy consumption or lower cost because of the hydraulic design pays a big chunk of the actual irrigation system capex.
So here's a question that I know that everybody's thinking, and I'll throw this because I gave Jimmy the hard one earlier. I'll throw this to Jakob. What if the valve doesn't open? Do I know this? Does the system tell you this?
Yeah, I don't think anyone.
You're welcome ahead of time for that.
I think that's nowadays a very basic functionality of any automation system of the sort of cloud connected type is to when you sell these systems, we always tell people you got to have a feedback, something that shows whether the valve opens. And at the minimum, that would be a main flow meter. But the ideal is a pressure sensor or a flow meter after each valve. But the minimum would be the main valve, and then you can at least see there's a feedback at the main water meter. But either works, so you can be fine-grained in your feedback, if you will, or you can be just decentralized in your feedback.
Yeah. So some of this seems complex. As customers are coming to you to get solutions, are you finding that the irrigation design community is up to speed on control, or are you guys engaging that for the customer to help design that system? Is it kind of a mix? Are some companies up to speed on designing around it, or?
You want me to start that? Yeah. Well, I think the design is the most important part of the process. And we think that the design, a good irrigation design, it should involve like 3 key aspects. For us is the agronomy, so the variability that you can find. Then the hydraulics, for sure, right? And also the operation of the system. You can get a lot of super small blocks, but no one is going to be able to operate that in an efficient way. So I think you should consider a balance in between the 3, and not because only the automation. I mean, the automation is a tool that helps us to be efficient, but efficient starts on the irrigation design. So, of course, you can tweak a little bit things, but then you have to consider that you don't work for the automation, you just work for the good, efficient irrigation design, and then you put the automation on it. Of course, you can do something that you can put some valves together, but not really big changes. That's for us, at least.
I would say that they are in general, they're up to speed on irrigation design and also automation, but when you get into the wireless stuff, there's more training necessary. They're not necessarily used to designing those systems with the line of sight between antennas and all of that's alien to most of them. So when we work with a new designer or reseller, we actually sort of encourage them to start out by the type of controller and that's back to your wired questions, that is basically a plug-in replacement for the traditional irrigation timers that they are used to, but takes it to the cloud. Because then they have something familiar to start with and learn on, and pretty quickly they will then be adding wireless sensors to that and get more sophisticated. But it's a good place to start as a sort of hands-on training.
Yeah, I think we're blessed in California to have some very good irrigation schools with design emphasis that we benefit from as automation vendors. As far as designing irrigation systems for automation, if it could be done easily manually, it could be done easily with automation. I guess one thing that may need more education is on the flow meters themselves, and position of where they are at the filter station. So as Jakob pointed out, having reliable feedback from the flow meter is really important to prevent, accidents or blowouts from happening. And so, we see in a lot of cases where the wrong flow meter was picked for the wrong, or a good flow meter was picked for the wrong spot, and so have a lot of in some cases have a lot of trouble connecting to the flow meter just because it's not reading properly. And then at the filter station, a lot of the new style mag meters are not compatible with fertilizer injection. So that's just one small critique, but otherwise I think the irrigation designers that we work with are doing a great job.
I'm actually gonna, shout out to some of the irrigation companies out there that have taken on the automation task and build an automation department and taught their engineering department and the design team how to design for automation. When I moved to California back in 2015, this was not even a topic, man. I would go to the irrigation companies and automation was not even, we gotta understand that this is a very small portion of the irrigation business. Most of the business is on the plastic, is on the PVC, on the drip lines. That's where the money is, and that's the projects that they're seeing. I like to tell them, you're selling a TV, but you're not giving them the remote control. And I'm sorry, man, but without a remote control, I'm not buying a TV, not now, maybe back in the 80s. But, so, and that was kind of like the speech, like, you gotta be able to learn remote controls, man. I'm sorry, it's a small portion, it's a hard portion. You need a dedicated team, it's not hydraulics, you need specific technicians that know electricity now that you didn't have. And in the last 8 years, I've seen some of these companies gear up, invest, just add on people just to be able to support their growers and add the technology component to the irrigation systems, which again, 8 years ago I didn't see it anywhere. And then there's other companies that are popping out that are providing services only around automation and irrigation management, which is actually...
Well, you raise a good point. So this concept of irrigation as a service, are you saying that that's picking up...
That's a thing.
Is that picking up speed? So irrigation as a service, basically it's a concept of you as a grower saying, I've got an automation system, I want assistance with running it, right? Yeah. And it could be different flavors, but is everybody starting to see more interest in that area with growers?
We've seen we've seen a lot of interest in terms of, having somebody to help out on not only the running the automation system, but also on the agronomic side. So we've added weather stations, so moisture probes, dendrometers, leaf temperature, there's a bunch of sensors out there. Yeah. The flora pool sensor that Andres mentioned. So there's plant sensors and how do I use all this information? So a lot of these companies have come in the door saying, okay, I'm going to help you make the decision. I'm going to help you read this data, interpret it, come up with a frequency and duration program for the week. And then they're gone, and then the irrigator is back to controlling the water, and then he doesn't follow the extractions exactly as the recommendation said. So you're not getting the actual value of the service because you're not executing the actual recommendation that was the optimum irrigation schedule for that case. So that's when automation comes in and it closes the loop. So now, there's companies coming out offering the recommendation, the hardware, the support and service, all as a package. And some growers are adopting it. It's a service, so you're OPEX, you're not CAPEX, so you're not investing. You're constantly you're paying a rent, a yearly fee, or part of the service. You're not getting technology obsolescence because these guys are renewing your technology as part of their service. So there are benefits around it. Yeah. But then on the other hand, there's the growers that prefer to own it, like the tractors and like the harvesters, and I want to have them under my roof, and I got a good team of agronomists, and they know how to run this boat, so I'd rather own it. So at the end of the day, it depends on kind of how you are approaching the use of the technology.
Yep. That's what I would say. So I know everybody probably wants to ask some questions, so I'm going to leave one hot one on the table because let's try to keep it brief, but the concept of fertigation. So we're irrigating, but fertigation is a very mature option at this point, correct?
Yeah. A couple of years ago, with the change in prices of fertilizer, it became a topic. That's
Yeah,
for sure.
yeah. With the cost of fertilizer, you know, anytime you irrigate, well, what's the really expensive stuff going out is the fertilizer. But are you seeing customers pick up on that? I know, Jimmy, you just came out with a new skid for doing fertilizer applications, but are you seeing customers embracing it?
Yeah, we're seeing customers embrace it. So I think the primary benefit is really for one, time saving, and then having confidence in delivering the right amount or the prescribed amount of fertilizer at the right time. So, yeah, several benefits we
Yeah.
see.
Yeah, well, we have done it.
Mike Andres.
Sorry, yeah. So we have done it in Chile. We do it all the time. In the past, I had the chance to work on a project with Patrick Brown over there that we continuously apply fertilizer through the irrigation. So this system allows you to do that. I mean, right now the controllers can allow you to not only apply by volume, I mean, just exact volume on fertilizer that you have on the tank, but also by proportion, right? So any amount of water that's going through the water meter, right? It injects the fertilizers in each irrigation, and we saw some benefits on that, but you need all the hardware to do all the stuff. You can fertigate by CE or EC in this case, or pH. So I think if you are already into automation, fertigation has to be into the equation,
Yeah.
of course.
Good.
I think
Good.
on the fertigation, just the timing of the injection is the key, and I think fertilizer companies and distributors and PCAs have figured out the fact that when you inject it is key, and if you're doing it continuously, and like Jimmy said, timing is key. We've run into ranches where I injected the whole 500 gallons last night and then just left the irrigation system running. We're like, okay, yeah, that fertilizer is probably like 5 feet deep by now, and that's okay. So it's the timing is crucial.
Yeah,
you want to put that at the end of the irrigation. You gotta calculate it so it stays on your root zone, so you can get the performance out of and then you gotta have the correct pH, because if you're irrigating with an 8.8 pH in the water, just might as well don't inject any fertilizer. So there's a combination of things where you can, based on timing especially, you can secure or increase the possibilities of success of the performance of the fertilizer.
Yeah, yeah. Okay, so we've got about 8 minutes left in the session, but it's the last session of the day. So if anybody wants to go a little bit long, we can, but let's open up to questions and see, what everybody out here has, because there's a lot to it. Yes, go ahead. Yeah, so if you have a lot of valves or in an irrigation set, they're all opening at once, how do you assure yourself that you're getting similar flows through each valve? Yeah, yeah.
That's a irrigation design
That's a
question.
Yeah, exactly.
So I'll let the hydraulic guy answer. But overall, what we've done is put pressure transducers after the valves, so we have a clear notion on what pressure you're irrigating on each valve. So that gives you, and you have a flow meter by the main line. The way to go would be potentially to have a flow meter by valve. That would be the dream. And then you would know exactly how many gallons you put on each block. But it gets a little bit pricey. So what we've done is usually put the flow meter on the main line and then just a pressure transducer at the valve level, so we just understand we're hitting there with the pressure that you need. And then again, downstream, you might have pressure compensated emitters or whatever you have downstream of the valve will dictate what's happening with the water. So it, there are devices that will give you pressure and flow. There's the money component, but
Absolutely.
Yeah, it's a hydraulic and economic question.
yes.
Do you want to put the sensing in to identify that? Yeah. So, go ahead.
Question for Andrew on the ET side. OpenET has a framework with a few, maybe 6 models. Could you explain how your data is available? Is that through one of those models or through another means for OpenET?
Yeah, I can answer this. So,
Oh, look, and we gave you a mic all to yourself.
yeah. So there are 6 models being run on OpenET. The website that Andrew showed, you can go and click on a orchard, pixel, whatever you're interested in, and it'll come up with a time series of all 6 models, as well as the ensemble. So the average of all 6 models, as well as the range in all those models. You can download the data for all individual models or the ensemble, whatever you would like to do. The ensemble, which is the mean, if there is a model that we see is acting a little weird in a specific orchard, so it's like, let's say it's 40% lower than the ensemble, it'll actually get kicked out and won't be included in that ensemble. And they also just released the API about 6 weeks ago, so you don't actually have to go to the website and click and download a CSV. You can write a script to talk to the API for any number of orchards. You just need a Latin long, and it'll pull that information and output it to your Google Drive where you can look at it.
My question was specifically which model uses your work? Or is it
Oh, our work?
model?
It would be the dyslexia model. So that's the one that's been included in T-Rex and GrapeX that we've been validating for. Sorry.
Anything from this side? Come on, somebody's got to have a hard question out there. It's a good panel. They got all the answers.
There's a question.
Another one here?
Devin.
Go ahead, Devin.
Yeah, so the way I think about automation, I think there's some relativeness to that term itself, relativity to that term. You know, full automation, I think, eliminates that scheduling process to some degree based off of observed information via sensors and transmission of that data and all that. So my question is, with the T-Rex project, if we get to a point of true ETA, how does that influence your scheduling design into your systems?
I think it's a great question. How does it affect them? And I would add to that, do you see that we will be able to ingest that information directly into the controller so the grower won't have to input that? I'd add on to that.
Devin, I think there's one step above that. It's in the new Sigma world, what can we do from a regulatory standpoint? I think that the information presented by Andrew earlier today will give us a great curve as far as applications during the year. But if we're only given 2.5 acre feet to irrigate, whereas the model would predict, say 45, 46 inches, we're going to have to figure out where we need to cut back on water. Yeah, as far as digesting information or digesting recommendations from other sources that that's available with from automation solution providers currently.
Yes.
I have a question, even though I'm not in the audience technically.
Oh,
but
no.
I'm
This could
just
be tough.
curious if there was in the audience any growers that actually had experience with this and maybe for many years and wanted to maybe share their journey and perspective on some of the things we've been talking about. Benefits and trouble.
That's a tough one.
If we don't have any takers on that, then we know we have zero penetration here at the Almond Conference.
I can see some people. It's just. Yeah. I'm going to go to what you did say, though, Devin. I'm going to go back to that question. We refer to that as autonomous irrigation. We still talk about automation of actually controlling the devices automatically. And autonomous irrigation would basically have let's call it the AI, control the irrigation if you want. We, as a company, we're not a modeling company, we're not running data, we have not gone into that, although we have a lot of data, because we have teamed up with, I would say, it's probably about 6 companies now that have developed their models, and on our scope to this has been open a full-blown control API. So if there's a recommendation, actually I had a meeting with the T-Rex team last week, if there is a model that can actually spit a schedule based on the model, we have an API that will
that can ingest it and, yeah.
that. So we're currently running it with a few companies here in the state and one in Australia, and they're just, we're ingesting their recommendation. So they take the data, they put it in the blender, as I call it, which I don't even want to know. And then they come out with a recommendation, or, it can be, a full AI machine learning model, or it can be a guy digging a hole and coming up with a schedule and then picking up the app and scheduling it for you. But on the modeling side, we already have, we have companies that have thousands of valves already under control with their own model. So that's available, as Jimmy said, and if you trust a certain model, we can close that loop through the API, just enabling the automation system to run whatever model you decided to use.
And that's really kind of a comfort thing from the grower, right? Are they comfortable with letting it do that?
Yeah.
Or do they want to step in?
I talk about like handing over the keys, and I call it like full keys or partial keys. So partial keys, they give you the rec and you have to accept it, and full keys is you're letting them drive, man. Yeah. So call them if there's an issue.
I think Sebastian wanted to weigh in too here on something.
Yeah, I just wanted to make a comment. This year's running sentence of the conference is connecting the dots. And in the morning, I moderated another session. Many of you probably were there, where we cover with 2 speakers, Patrick Brown and Thomas Harter, 2 great professors at UC Davis. They shared their results about fertigation and about how to enhance nutrient use efficiency. And one of the things I took away in the morning was how continuous fertigation really helps you to improve that efficiency and significantly, and ultimately save costs and also reduce pollution, either because of leaching or because it's going into the air. So they did talk about the role of automation into fertigation. And in the morning, there was also emphasized how you can increase that efficiency if you move from episodic fertigations to continuous fertigation. So just want to connect the dots a little bit with what we talked in the morning with what is being talked today, because that's why we are here today, connecting the dots.
Yeah. Thank you.
I would like to add a little bit about autonomous irrigation. Something that we have to keep in mind as well is the safety issues about autonomous irrigation. We are talking about, I guess with autonomous tractors and sprayers, they have the same kind of discussion, right? We are talking about the system that it has to be maintained. And if it runs autonomously, you have to take care about safety issues. Maybe someone is, fixing some stuff, and it turns out in irrigation on the model, which is great, but something can happen.
And that's the advice I gave to a grower 20 years ago who asked me if he could automate a system, and his motivation was so he could live in Hawaii and manage his almonds in Durham from Hawaii. And I said I didn't think that was a really good idea at that point. Well, we've kind of hit time, so I want to thank first Andrew for leading us off and kind of helping us see where we're going in the future with understanding this when and how long, and how to make that really easy for us. and then the panel for weighing in. This is a lot of experience here after we finish up. If you want to talk to any of them, I'm sure they're going to hang out for a few minutes. But it can be a daunting and frightening thing to move into this stage, but every grower I've talked with that has gone into automation is incredibly thankful they did it. Yes, there were learning pains early on, but at the end of the day, they came out far better than when they started. So.